Welcome back to the next series of question 6. The standard reduction potential of copper 2 plus in copper and Cu2 plus in Cu plus or respectively 0.337 voltage for copper 2 plus in copper, 0.153 voltage for copper 2 plus in copper. The standard electrode potential of Cu plus in Cu of cell, it is not given. So for these two potential are given for this two obsels, but this obsel is not given. So we should calculate it for each Cu2 plus in Cu. So Cu2 plus to Cu, this is 2 plus, copper is atomic state 0, difference is 2 plus and 0, 2. That 2 is considered as an electron. We should put near the higher oxidation number side, this side, 2 electron. So it is it only where the higher oxidation number present, that side only we should put a number of electrons. That equation, it determines whether it is oxidation reaction or a reduction reaction. Here it is a reduction reaction because it gains the 2 electrons. So the E1 naught value is nothing but 0.337. So we know delta G naught equal to minus NF E naught or minus delta G naught equal to NF E naught. So delta G naught 1 is equal to minus NF E naught. Minus N is number of electrons, F into E1 naught is 0.337 voltage. So minus 0.674 Faraday. Then for second case, copper 2 plus. Here copper 2 plus in copper plus. The voltage is 0.153 is the second voltage. So delta G naught, delta G naught equal to minus N of E naught. E naught, N is nothing but number of electron 1 because copper 2 plus is converted to copper plus. Here 2 plus, here 1 plus, the difference is 1. That 1 electron should be put near the higher oxidation number side, it is 1. So it is a gain electron, it is reduction reaction. Delta G naught value, it is minus N of E naught 2 value. So E naught 2 value is 0.153. So substitution value, N is number of electron 1, F as it is standard value only, and E naught value is 0.153 voltage. So multiplication delta G naught 2 is equal to minus 0.153 F. Then third option, Cu plus and Cu. Cu plus to Cu. Here plus 1 and here 0. That 0 and 1, the difference is 1 electron. Put near the higher oxidation number, 1 electron this side. So even this also reduction. Delta G naught equal to minus 1 F E naught 3. So delta G naught is equal to minus E naught 3. E naught 3 value is not given. We should calculate only that. So equation 1 minus 2 is equation 3. This is equation 3. So equation 1 we got it minus 0.374 F. And second value we got it as minus 0.153. So here minus of minus plus, so here plus value, and after getting this subtraction of this value, we are getting minus 0.521 equal to minus E naught 3. Minus minus cancelled. E naught 3 is equal to 0.521 voltage. So 0.0521 voltage is the correct answer for this option, copper plus in copper. Next question. Zinc in zinc 2 plus is 0.1 molarity and in salt bridge, and Fe2 plus the concentration is 0.01 and opsel it is single vertical line, it has been a Fe. So the EMF of the both cell is 0.2905 voltage. Equilibrium constant of the cell reaction is, we are asking you to find out equilibrium constant of K. The values are given in the raised powers of 10. So the cell reaction first of all we should write. This is A and this is B and this is C. A means anode and C means cathode and linked with a salt bridge. Anode I told you oxan, cathode I said red cat. Oxan means oxidation. Zinc plus Fe2 plus and zinc 2 plus Fe. E cell is there given in the question, that is 0.2905 voltage. So I have written here A, B, C. Oxan, red cat. This is oxan and this is red cat. The concentration of zinc is 0.1 and Fe2 plus concentration is 0.1. Here they have given 0.1, here 0.01. For zinc 0.1, for Fe2 plus 0.01. So we know the Ernst equation. E cell is equal to E naught cell minus 0.0591 by n log K. N is equal to number of electron involved is 2 electrons. And log K value is product divided by reactant. Here product is Fe2 plus and reactant is, zinc 2 plus is the product and the reactant is Fe2 plus, product by reactant. Here the product Fe also, but the activity of the solid metals is equal to 1. We should consider the activity of solids, any solid equal to 1. So here Fe is equal to 1. Here Zn is equal to 1. So product divided by reactant. Product is zinc 2 plus concentration divided by reactant Fe2 plus concentration. So when you exchange this, E naught cell is equal to this side of 0.0295. Make the sign plus 0.059 by 2 log zinc 2 plus value concentration is 0.1, Fe2 plus concentration is 0.01. So that is considered as a 0.32 voltage. Let us see this. E naught is equal to 0.059 n log K. Log K is equal to n E naught, cross multiplication, n E naught divided by 0.059. So we found out this, all this we are getting 0.32. So n is equal to number of electrons, that is nothing but 2, and E naught value is 0.32 divided by 0.0591. So and divide this 2 and 0.059, 0.0295. So 0.32 by 0.0295. So this is equal to log K. So K value is equal to 10 raised to 0.32 divided by 0.029. Is the correct answer. And give E naught, chromium 3 plus in chromium minus 0.74 voltage. E naught MnO4 minus Mn2 plus 1.51 voltage. E naught Cr2O7 minus in Cr3 plus 1.33 voltage. And E naught Cl2 in Cl minus 1.36 voltage. Based on the data given above, strongest oxidizing agent will be. Strongest oxidizing agent. The strongest oxidizing agent is nothing but greater the positive potential value. So here the greater positive potential is 1.51 for MnO4 minus. The strongest oxidizing potential will be self-reduction. So it has the highest value. It is plus 1.15, 1.51 voltage highest value. So MnO4 minus gives Mn2 plus. Here plus 7, here plus 2, difference is 5. That 5 is nothing but 5 electron put near the higher oxidation number side. So it has a gain 5 electrons, so it is a reduction reaction. Undergo self-reduction. So answer is MnO4 minus. MnO4 minus in Mn2 plus alone carries a higher positive potential. It is a strong oxidizing agent. Question number 9. Two aqueous solutions A and B containing solute of copper sulfate and sodium bromide respectively. A is copper sulfate, B is a sodium bromide. Were electrolyzed using platinum electrode, the pH of the resulting solutions will be shown as increase in both solution, decrease in both solution, increasing A and decreasing B, or decreasing A or increasing in B. First of all, we should know what is the electrolysis of copper sulfate and a sodium bromide. There is a quick process to identify the products at a cathode and a anode. To get a product at cathode, to get an anode at as a product, we should remember these key points. This is not binary. Ions have higher reduction potential will be reduced first at the cathode. Ions having higher reduction potential will be reduced first at cathode. In a cathode, as a get a product at the anode, ions have a higher oxidation potential will be oxidized first at anode. Ions have the higher oxidation potential will be oxidized first at anode. Let us see case A. Case A is nothing but copper sulfate. Reduction potential of water is less than the reduction potential of first B group, second B group, and 13th group. 13th group is nothing but boron family. So these are cations other than first A, second A, and 13th group elements. Other than. So the reduction potential of first B groups, alkali metals, lithium, sodium, potassium, rubidium, cesium. And second B, first B is nothing but a copper, silver, coinage metals, copper, silver, gold. Not first A. First A is alkali metals. First B is a coinage metals, copper, silver, gold. Second B is nothing but zinc, cadmium, and mercury. Second B elements. So first B, copper, silver, gold. So the first case, copper sulfate, they have given in the question. A is the solution of aqueous solution. Aqueous means water content. Aqueous solution of copper sulfate is nothing but first B. And aqueous solution of B is the second solution of sodium bromide. That is nothing but first A. This is first B and this is first A. So first B is a coinage metal. So first A is nothing but alkali metals. Sodium, potassium, rubidium, cesium, francium, like that. So here copper sulfate, copper is nothing but A, that is belongs to first B group. It is a coinage metal, copper, silver, and gold. So let us see this case A. Aqueous solution, water content, the reduction potential of water is less than the first B of copper sulfate. Copper sulfate, example, copper 2 plus ion, silver chloride Ag plus ion, auric chloride Au3 plus ion, cadmium chloride Cd2 plus ion, zinc chloride, zinc 2 plus ion have a higher reduction potential. As per the rule, the ions have the higher reduction potential is reduced at a cathode. So copper sulfate aqueous solution means water content. So copper sulfate aqueous solution gives copper 2 plus 2H2. Copper 2 plus gives copper, that is a higher reduction potential, less reduction potential of water. So reduction potential, red cat reduction potential, copper 2 plus 2 electron gives copper. So 2 plus is reduced to copper. So copper is deposited at a cathode. Copper 2 plus gains 2 electron, undergo reduction. So reduction takes place at a cathode. So copper is the product at cathode. So as per the rule, I said the ions having higher reduction potential will be reduced first at a cathode. So copper reduced at a cathode. Next, anode water aqueous solution. 2H2O gives O2 plus 4H plus 4 electrons. So the point is, when the hydrogen ion concentration increases, the pH will be decreases. For case A, copper sulfate, pH will be decreases because pH is equal to negative logarithm of H plus ion. So H plus ion increases, pH will be decreases. So where it is the point, option A is decreases. A is decreases in pH. Now we should find out the automatically increases in a B. Let us prove that whether it is increasing or not. Next, case B we should see. So in case A, solution of copper sulfate in water, cathode red cat and anode oxide. Already we discussed the reactions. Copper 2 plus gain 2 electrons and gives a copper. So it is reduced. First it reduces copper at a cathode. An oxidation of water and O2 plus 4H plus and a 4 electron loss of electron oxidation takes place. So H plus ion concentration is increases. H plus ion concentration is increases. The pH is decreases in case of A. Next, a product at a cathode in case B. The reduction potential of water is greater than the reduction potential of cations of first A, second A, and 13th group elements. First A, I said alkaline alkali metals, and second A is alkaline earth metals. So alkali metals, sodium, lithium, sodium, potassium, rubidium. So under that, sodium, in our question, sodium bromide is given as a second solution, aqueous solution. You see, the second aqueous solution is sodium bromide. It belongs to first year alkali metals. So alkali metal example, sodium chloride, potassium chloride, cadmium chloride, mercury chloride, aluminum chloride cannot be reduced because as per the rule, higher the reduction potential, reduced first at a cathode. So because higher the reduction potential of water is greater than the alkali metal first year, alkali earth metal second year, and boron family 13th group elements. So here H2O, 2H2O gains 2 electron, gives 2H2 plus 2OH minus. So here H2O gains electron, undergo reduction at a cathode. So it releases H2 gas at a cathode. So halogens, I mean case B, oxidation potential of water is less than the oxidation potential of Cl minus, Br minus, I minus. So oxidation of these ions occur at the anode. So Cl minus, Br minus, I minus at a higher oxidation potential. This ion undergoes oxidation at the anode and releases Cl minus releases Cl2, Br minus releases Br2, and I minus releases to I2 gas. So at anode, 2Cl minus gives Cl2 gas plus 2 electron, 2 Br minus Br2 gas plus 2 electron, 2 I minus gives I2 gas plus 2 electrons. So these are the oxidation. It takes place under anode. So Cl2, Br2, I2 gases are released. So at cathode, 2H2O plus 2 electron gives H2 plus 2 OH minus. H plus ion gases decreases. So what pH is increases. So case B, pH increases. So in the question, H plus, pH decreases in A and increases in B. Opposite of H plus ion concentration. If H plus ion concentration increases, pH decreases. H plus ion concentration decreases, pH increases. So in case A, it is decreases the pH, and case B, pH increases. So this is case B, cathode and anode. So here H plus ion concentration is decreases, so the pH increases. Last question of this session, the set of the question is given that E naught Fe2 plus and Fe3 plus equal to 0.44 voltage, and E naught for Fe3 plus and Fe 0.77 voltage. If Fe3 plus and Fe2 plus and Fe solid or Fe solids are kept together, then Fe3 plus increases, Fe3 plus decreases, Fe2 plus and Fe3 plus remain unchanged, Fe2 plus decreases. So here in this Fe2 plus, Fe3 plus and Fe. E naught, Fe3 plus and Fe2 plus 0.77 voltage, it is given. And E naught 2 plus and 3 plus is given minus 0.44 voltage. So highest reduction potential, if it is a positive, strong oxidizing agent, undergo self-reduction. So Fe2 plus is changed into Fe3 plus. So the difference between 3 plus and 2 plus is 1. That 1 electron should put near the higher oxidation number side this side. So it has gained electron. So it is 3 plus is reduced to 2 plus. So Fe gives Fe2 plus plus 2 electron, because 3 here's 0 and here 2 plus. Difference between these two is 2 electron. The 2 electron we should put near the higher oxidation number side. So this is oxidation. So anode, ox-an, and this is red cat. This is red cat. Here 2 electron is involved, so multiply this equation by 2. The whole equation should be multiplied by 2, but the E naught values, the standard values should not be multiplied by any other number. It should not be changed. Only the equation gets changed in order to get an equal number of electrons. So multiply by 2, 2 Fe3 plus 2 electron gives 2 Fe2 plus. So we found that this is oxan, this is cathode. So E naught cell is equal to E naught cathode minus E naught anode. So E naught cathode value is 0.77 minus E naught anode values minus 0.44 is nothing but plus. So we are getting adding plus 0.77 plus 0.44, you are getting 1.21 voltage. 1.21 voltage is the Fe3 plus, the voltage is decreases. Here it is minus delta G naught is equal to NF E naught. E naught value is positive, delta G naught minus value means it is a spontaneous reaction. So Fe3 plus is decreases well. This is decreases. Thanks for watching.